Welcome back to the hyperbolic coding chamber. We are back once again. The process of deforestation continues because we are in the midst of battling the binary trees. So it remains to be seen if we can conquer this villain. But if there's anything I've learned from the hyperbolic coding chamber Discord, is that we can accomplish anything. So hopefully we can get through this. At the same time, we have completed the break. The break is over because I was off this past week and today as well. So we'll probably be back to work tomorrow. But I'm feeling optimistic that I have a good feeling about this second run. So basically I've been trying to decrease my binging, decrease the binging, the dopamine binging, and just kind of take it a bit slower, and things have been going well. And yeah, I'm pretty excited about that. At the same time, I'm thinking that I'll try and have the first devlog up by the end of this week. I think I just need a little bit more footage, but we'll see, right? I will try to get up this week and see if we can get into a motion of it. But the break was very, very nicely received. And yeah, I guess I'm definitely feeling rejuvenated. So definitely time to sprint. At the same time, we had quite the year on LeetCode, so it remains to be seen what this year holds in store, but it could be pretty epic. At the same time, I was just revisiting a quote, and I think it was from the Ultra Learning book, which is basically about how to learn something quickly by a pretty cool person. But basically, I think the quote was saying, we all know this, pushing past your limits is some of the best ways to learn. But at the same time, I worry about retention, and I do think sometimes the really difficult problems, like when we used to do mediums or hards, they just weren't retained very well. Like, I feel like I'd learned something very, very specific, and because I was bouncing from problem to problem, I never really got a chance to abstract the concept that I learned out to be usable in other problems. That was kind of the worst. So what I have learned is that, so we started switching to doing all easies. And with the easies, we've done so many problems. Now we're kind of cooking through some of them now. But I feel like a lot of the patterns that I learned are much more abstract now. I see them in a much more abstract light than something like, oh, 2 pointers has to mean this. I see it like more abstract now. So sometimes the problem's difficulty is simple, and that's okay. And sometimes it's just about abstracting the model maybe. But that's been pretty useful. Unfortunately, though, the problems I think we're working from easies, right, with the most frequency going downwards. But I think the problems, we're not having as much difficulty as we used to. But I think we're in for a change because we've been working on a BST problem, and it has been cooking us. We're getting cooked. So maybe things are up for a change there. So that being the case, I was expecting maybe we'd speed up, and it seems like we are. And we're running into some harder problems, so that's good. That being the case, I don't think there's much else to say, except if you're interested in something like this, you should definitely join the Hyperbolic Coding Chamber Discord, where we are rapidly expanding, and we also have awesome talks and cheat codes and the best resources. Best asterisk resources. So, so I think we're just going to jump into today's session. So I think we're working on a version of this problem. We basically have a problem called kth largest element in a stream, which is pretty much a problem where we have to return given a starting array of integers. Sometimes actually I'll be right back. So we are back. Gonna do a classic hour session, and just set the timer up real quick. So we're good. So we had kth largest, right? We're pretty much given a starting array of integers, which we have to load into some sort of data structure. And then there's going to be a call to a function called add, for which you have to return the kth largest number based on adding this number to that list of numbers. We're also given a k on the constructor, which tells us the kth largest number to add. We could just load all the numbers into an array. Every time we call add, we'll add the number to the array, sort the array in descending order, and then from there we'll just return the kth minus 1 element to get the kth largest element. The problem with this is that add would then take n log n time. I think we could do a little bit better with the BST. So we implemented a BST by implementing a binary node. We made two functions, insert, which would insert into a BST, and print, as well as build, which allows us to build an array from the BST. For some reason, this solution takes 6 seconds. And it's actually slower takes 4 seconds sometimes. It's actually slower than just sorting the array. Then we tried to, now I remember, then we tried to time everything. If we take start as date now and end, we tried to time everything. But it was kind of hard to tell why everything was taking so long. It looks like it takes about 5 milliseconds. I don't know. We remove this constructor time version and paste it down here. Let's just check how long it takes to build the array on each call of add. It's kind of balls. pretty sure if we run this like last time, it's going to... Yeah, it did freeze last time when we clicked the second case. It feels like it takes less than a millisecond. And if we just check insert time instead, it's really hard to tell how much time things are taking. That being the case, what if we just added early stop to build? So instead of actually doing build, we'll just return find this dot root this dot k. Could we implement something with early stopping? But I feel like in reality it doesn't really matter, because worst case you'd still have to visit the entire array anyway if the kth value was... Wait a second. If we have the tree from earlier, For example, if we're working with something like 199 and 48, if we wanted to get the kth largest value, let's just say the kth largest value is 3. If we add a new value, if we had a new value, like let's just say 101, the third largest value goes from 48 to 99. If we had a new value like 150, the third largest value would be 100. If we had another value, it would be 101. It seems like we could make add cost just the insertion time. This would be log of n. Could we simplify this? So then we could just keep track of the kth node and then slide it up. To do this though, you would need to have access to a parent, which would still be fine, but we'd have to create a new parent node. We'll just add it at the end. We'll just say parent can be a B node or null, and then we'll say it defaults to null. Right, if val, let's just say 1 less than 48, and you don't, and 48 doesn't have a thing, then we say node.left is equal to new b node val, the null left and null right, and the parent will be the node itself. And let's just say trying to insert 50, and 50 is greater than 40. And say node dot and 40's right node doesn't exist. Let's say null node. And we'll also do parent I'll uncomment the test we used to do originally, and they shouldn't change. All of this should still work basically. One 140's parent is 150, 150's parent is 100, 75's parent. Okay. And then we could just have another thing. This is a class, so we can just have something called kth node, which will be a b node. And then we can comment all this out again. And the goal with this would be to pretty much keep the B node. We'd load a lot of the time taken in the constructor. Once we have access to the kth node, we can just add it to the tree and then slide the node up once. We could still keep the build function, which would take an array, except instead of pushing the node's value, we're actually going to push the node itself. And it's going to be an array of B nodes. And then the kth node is going to equal to this. It's going to equal to the array this dot k minus 1. And when we add a value, we can just insert it into the node. We shouldn't have to build anymore. We should have to say this dot next largest, and we should just have to pass in this dot kth. Or we can just say and then return this dot kth node dot val. But only when a number added is greater than it. I actually just realized. So if this dot kth node dot val is less than the new is less than the new value we're adding, means you have a new largest. So you have to move the node to the next largest. Let's say function move node to next. I have kth node, which will be a B node. We're not going to return anything, and we're just going to say we just have to add some specific code, right? Because if you're in the left half of the tree, right, if you have a parent, it means you can if you have a parent, if you're on the left side of the tree, it means you can go up. Well, we pretty much have to go up. So if your parent is greater than you are, then you would go up. But if your child is greater than you are, then you would go down. So we can say if kth node dot parent and kth node dot parent dot val is greater than kth node dot val, we can just say and then we have to modify this to return a B node. So if the parent is greater than the current value, right, then we want to say, then we'd like to return kth node dot parent, right? I have an else if the parent, it might make more sense for this case to be first. If the kth node, if the parent doesn't exist, right, then you would just return kth. Actually, I'm realizing it doesn't really matter. In the else case, you can just, or out here, you can just return kth node dot right. So what if the right node doesn't exist? So they expected 4, 5, 5, 8, 8. We got 8, 10, 10. You start with 4, 5, 8, 2, then the kth largest node would be 5. When we add 3, the third largest node would be 4. When we add 3, it's still 4. When we add 5, it's still 5. When we add 10, the kth largest node would be 10, 8, 5. Wait a second. When we add 10, we'll have 10, 8, 5. I see we added a number that was greater than 5, so we went up. Right, but the find next largest node, we're not making. When we do find next largest node, we have to take the extras into account. So we're having, for the node, if kth node extras traversed is less than kth node dot extras, right, then we'll say this dot our kth node dot extras traversed plus equals 1, and then return kth node. I think we're missing one more. No, wait, because when we're not less than extras, then we would actually count that node. It's just showing that that is working, I think. Oh my god, right. If the root node doesn't exist, then we do have to run build and set the kth node. The problem here is after we do insert, it's possible the kth node doesn't exist. If it doesn't exist, then we should just build the array for the first time and set it and find it. Otherwise, it does exist, and if it does, or I guess we can just say else if this dot kth node I think we should be good here. So now you have 3, 5, -1. So now we're getting straight 5 back. Created 5. -1. The kth largest value doesn't even exist yet. Expected -1.
Sign up for YouTube Premium and get ad-free videos and music. Try it today.
Maybe this idea was a pipe shoot. I'm gonna comment all this nonsense out and just try to return or find one. I have function find, which takes a node, which is a B node, or can it be null? I don't think so.
When you sign up for YouTube,
We have
Premium,
cur
you can
k,
watch
which would
videos
be
ad-free.
a
Download
number,
them to
and then we
watch
have
offline.
goal k.
And keep them playing
I guess we
even
could just
when
have
multitasking
regular
other
k,
apps.
and it should return a number.
Sign up for YouTube Premium and get all your videos
And we'll say
ad-free
if
offline. Try YouTube Premium for 1 month on us and get into what you're into.
say node, say yeah, I think we're going in circles. Even if you did the early return, you still at worst case end up visiting the whole list. It should just be linear time. It's so different than build. I don't get it. However, to add a new element, we first need to find where the element should be inserted and then insert it by shifting the array. Add elements in log bin time. This is what we mentioned though. I think we didn't know how to implement one. And perform insertions and removals while always maintaining the first property.
Don't go in there! No Wi-Fi. Okay, I'll just chill then.
Matt, with YouTube Premium you can download videos to play offline. We're still watching.
Oh.
Get YouTube Premium. All YouTube, no interruptions.
Now that we know what a heap does, how does it solve this problem? Oh, rip. I mean, this is what we spaced. I didn't think of using the min heap though. That's pretty clever. I thought I was just gonna reinsert them back into the heap, but that is clever. But yeah, I figured we needed a heap. I just didn't know how to implement one. Time complexity n times log of n plus m times log of k. Oh, right. Maybe we should. Oh wait, the badge shows up. Feel strong, man. Feel strong. It don't get any better than that. Maybe we should do some heap problems.
YouTube Music Premium is an experience that gives you complete control of your music. So you can listen ad-free, download music for offline play, and keep your songs playing in the background. Get YouTube Music Premium.
I'm curious if LeetCode has a heap problem set. Yeah, maybe they'll show us how to implement a heap. Okay, yeah, this is perfect. So, yeah, LeetCode Explore cards are slept on, man. So I guess we'll just go through this then, and we'll work on this, because this is like the third time a heap has come up, and we said we'd learn it, and we put it off. So, the content on this card is exclusive to our premium. Largest or smallest element in the data set. We do not care about the order of other data in the data set. How do we efficiently access the largest or smallest element in the current data set? Heap data structure and implementation. A better understanding of the concepts and methods of max heap and min heap. Have a better understanding of heap sort. Let's first talk about a priority queue. A priority queue is an abstract data similar to a regular queue or stack data structure. In a priority queue, an element with a high priority is served before an element with low priority. Common misconception. Heap is not a priority queue, but a way to implement a priority queue. There are multiple ways to implement a priority queue, such as array and linked list. However, these implementations only guarantee constant time complexity for either insertion or deletion. Or the other operation will have a time complexity of linear time. On the other hand, implementing the priority queue with heap will allow both insertion and deletion to have a time complexity of log n. So what is a heap? Definition of heap. According to Wikipedia, a heap is a special type of binary tree. A heap is a binary tree that meets the following criteria. It is a complete binary tree. The value of each node must be no greater than or no less than the value of its child nodes.
Soothing sounds. And now you're ready to fall asleep. Keep your ASMR video playing, even with your screen off. Try YouTube Premium on us.
Heap has the following properties. Insertion of an element into the heap has a time complexity of log n. Deletion of a heap from the heap has a time complexity of log of n. Maximum and minimum value in the heap can be obtained with constant time complexity. Two kinds of heaps, max heap and min heap. Max heap, each node in the heap has a value. There are two kinds of heaps, max heap and min heap. Max heap, each node in the heap has a value. Two kinds of heaps. Max heap, each node in the heap has a value. Each node in the heap has a value no less than its child nodes. Therefore, the top element has the largest node in the heap. I see. You pop one, then two would become the min heap. Okay, yeah, I think I'm definitely confusing a heap with a BST. How is this a min heap? Each node in the heap has a value no less than its child nodes. So 2 has to be less than 4 and 5, and 3 has to be less than 6 and 7. In a min heap, each node in the heap has a value no larger than its child node. So 9 is the biggest element. 8 is bigger than 6 and 5, 7 is bigger than 4 and 3. So where would you place a value like 2 then? In the left subtree or the right subtree? Insertion means adding an element to the heap. After inserting the element, the properties of the heap should remain unchanged. Yeah, I see why our BST-based solution didn't make much sense. Yeah, the heap. I think I was trying to make a BST, but it had basically nothing to do with what we were doing. So I think we'll stop there.